All right, more logs, more logs, more logs, man. Here we are with assignment 5, and here we are talking about quote unquote expanding and condensing logarithms. So the majority of what we're going to be talking about right here, right now, is they can be boiled down to 3 simple little tricks. And here's what these 3 things are. 3 things that are necessary for expanding and condensing stuff. All right. Let me just actually, before I get too far. Okay, there it is. The simple concept is this. I'm going to write it out and then I'm going to explain. Okay, 1 is when there's an inside multiplication. Another is when there's an inside division. And the last one is where there's an inside exponent. Okay, these are like kind of like the big 3. All right. And what we can do when we have like these situations is this. If I have a multiplication, that is the same thing as an addition of individual logs. Okay, that's the same thing as an addition. So it's kind of like the idea in a multiplication problem. What do you do with exponents? You add them. Kind of idea. Similar to this. Okay, what do you do in a division problem? What do you do to exponents? Well, you subtract them. And that is true as well. So this would be log A minus log B. So inside multiplication is outside addition. Inside division is outside subtraction. And then the last one, what do you do when you have exponents is, well, you multiply. So simplistically, this is what you do. You take this exponent and you drop it up front. So this would be just a regular b times a log of a. So that b was originally the exponent on the a. Correct. So what we are going to be asked to do in today's assignment is either expand, okay, expand your logarithm, or condense your logarithm. So expand means you spread it out as much as you can. Okay, you spread it out as much as you can. And then you, that's what you want to do. If you're trying to condense it, then you try to put it all back together. Okay. When you expand, if we're asked to expand, okay, what I encourage you to do is handle all multiplications and divisions first. All right, so turn all multiplications into additions, divisions into subtractions. Do all of those things first, and then worry about your exponents. Okay, aka dropping them down as a front multiplication. Okay, that's what you should do when you expand. Turn everything into like individual pieces. So look where there's any multiplications and divisions and expand those things out, and then worry about your exponents. When you're asked to condense, do the exact same thing but backwards. All right? So what you should look for first is those exponents. All right, so any number that is up front, go ahead and put it up as an exponent. And then look at any additions and subtractions, and they ultimately turn into multiplications and divisions. Got the letter N. All right, you get the idea. Okay. So expand. Here we go. So what I have is 16 times x squared. Okay, that's what I have right now. Okay, so the first thing that I do is I look for any multiplications and divisions, and I turn those into pluses and minuses. So right now, I have the log of 16 plus the log of x squared. Okay, so any multiplications and divisions, I turn into additions and subtractions. And then what I do is I analyze what I have and I look for any exponents. I have an exponent there, so that's the second thing that I do as I handle my exponents. So this is log 16 plus 2 log x. And that's your expanded logarithm. All right, here we have 55 times x. All right, so what I do is I turn any multiplications and divisions into pluses and minuses. So this would be log 55 plus log x. Then I analyze my answer. I look for any exponents. I don't have any exponents, so that's as good as it gets. Okay, here they're trying to get a little bit tricky. This is an x to the second power, but it's to the third root, so that's technically to the 2/3. Okay, we learned how to rewrite roots a few chapters ago. All right, so in this problem, there aren't any multiplications, but there sure is an exponent. And so all I have to do is I have to take that exponent and drop it down. So that's going to be 2/3 log x. Okay, here I have x to the 1/2 times y to the 3rd. So the first thing that I do is I look for any multiplications and divisions. I do have one right there, and I'll turn that into a plus. So that's going to be log x to the 1/2 plus log y to the 3rd. As soon as that's accomplished, I analyze my problem and I see any exponents are going to drop in front of these logs. So this is going to be 1/2 log x plus 3 log y. There's your expanded logarithm. Okay, now we want to condense them. Let me just rewrite the exact same thing that they have here with some parentheses. All right, so before what we did is we looked for any multiplications and divisions, and we turned those into pluses and minuses. And then we worried about the exponents. Well, here we do the exact same thing, but backwards. We look for exponents, and then we worry about the multiplications and divisions. So here, I'm going to gather up this 5, and I'm going to put it up on the x. I'm going to gather this 2, and I'm going to put it up on the y. So this is the natural log of x to the 5th minus the natural log of y to the 2nd. So I get all of those exponents squared away. And then I worry about the additions and subtractions. Okay, I see that this is a minus, which is ultimately a division. So this is going to be the natural log of x to the 5th divided by y to the 2nd. Okay, here we have a log of 3x, a log of 10. Okay. So there isn't any numbers up front, so I'm looking for, numbers in front of these logs. So if there were a number, I would put it up as an exponent, but I don't have any of those things. So I can kind of cut right to the chase and look at all my pluses and minuses. Pluses are multiplications, minuses are divisions. So I see that I have a division here. And so this would ultimately be 3x divided by 10. Okay, here I have the ln of 3 minus 3 ln of y plus 1/2 ln of z. Okay, so the first thing that I do is I take any of these front numbers and I put them up. 3 goes up on the y, 1/2 on the z, etc., etc., etc. Then any subtractions are divisions, any additions are multiplications. For simplicity, what you can do is you can put them on tops and bottoms. All right, so here I have a 3 on top. I have a y to the third on bottom, because that was a division, and then I have a multiplication and a z to the 1/2. So anything that was pluses or positives are on top, negatives or divisions are on bottom. Which of the following is not correct? Let's take a look here. Let me kind of condense this previous problem down a little bit. All right, so here, the first one I see an addition, so that would imply multiplication. So this is, in essence, log 2 of 18 times 18. Okay, 18 times 18 is not 36. This is log 2 of whatever 18 times 18 is. Yeah, 324. So that one's not correct. Okay. Okay, again, addition implies multiplication. So this is log 2 of 3 and 12, so 3 times 12. So that's log 2 of 36. That one's good to go. That one's fine. 2 and 18, 36. 4 and 9, 36. 6 and 6 and 36. All of those are 36, except for that 18 and 18. So the only one that is not right is that first one. That's the only one that's not correct. All right, so condense. Here's how I'm going to do this right now. I'm going to see this as 1/3 log x plus 1/3 log y minus 4 log z. Okay, so the first thing I do is I bring up these exponents. So that's going to be log x to the 1/3, log y to the 1/3, and log z to the 4th. Any positive numbers are on top, any negative numbers are on the bottom. Actually, this has to be inside a single log, sorry. Start there. So that means an x to the 1/3 is on top, a y to the 1/3 is on top, and a z to the 4th is on top. Okay, so the first thing I do is I take these numbers and I put them up. So this would be log 8 to the 4th. And then the subtraction is a division. So this is log of 8 to the 4th over 10. Okay, so simplistically, again, these are the big three. So an inside multiplication is an outside addition and vice versa. Inside division, outside subtraction, again, and vice versa. And then we have the exponents where if it's on the inside, it drops, and if not, you put it back up.